The known universe is about 93 billion light-years in diameter, and is filled with 10 to the 54th kilograms of stuff. And yet physicists say the whole thing came out of nothingness during a single Big Bang nearly 14 billion years ago. How this happened is perhaps the most fundamental question that science can tackle. How, exactly, do you get something from nothing? It all starts with entropy, which is just a fancy way to talk about disorder. Nothing is as disordered as, well, nothing. You can mix it up, scramble it, rearrange it all you want, and you still have nothing. Something, on the other hand, is orderly. You can't scramble up an atom and still have an atom. So nothing has higher entropy than something, and entropy, on the whole, never decreases. So it seems impossible that nothing could ever turn into something. But there may be a loophole. One form of Heisenberg's uncertainty principle says that a system can't ever have precisely zero energy. And because energy and mass are one and the same, this means that nothingness isn't quite as empty as you might think. If you somehow removed everything from the universe, you'd still find particles popping in and out of existence, caused by nothing but the fundamental randomness inherent in quantum mechanics. But how do you get from random particles here and there to an entire universe spontaneously forming out of nothing, and lasting for billions of years? The other half of the uncertainty principle says that physical objects can trade time for energy, and vice versa. For instance, something can pop into existence with a lot of energy if it only lasts a short time, or it can last a long time if it has very little energy. And physicists now believe the universe has as close to zero total energy as you can get. Why? Gravity. Gravity is the only force that always attracts, and that, counterintuitively, means it has negative energy. It counteracts the positive energy of the expanding universe. With its total energy near zero, uncertainty allows the universe to exist for potentially a very long time. But it doesn't explain how it grew from a tiny quantum sprout to be so mind-bendingly huge. For that you need inflation, which cosmologists think drove the early expansion of the universe. Observations of distant galaxies and cosmic background radiation suggest inflation was real, but what caused it is still a mystery. In the end, regardless of how the universe got to be so big, the laws of physics suggest that all of its energy, and hence all of its stuff, may add up to zero. So taken as a whole, the universe is just a strange form of nothing. Seen this way, the question of how you get from nothing to something doesn't make any sense. Something and nothing may well be the same thing. There's much more to the story. Read about it in the July 23rd issue of New Scientist.